All right, so let's jump in, do some examples of these guys. Go ahead and copy this down. How do we graph in example 1? Graph the solution set of x is less than 3 and x is greater than or equal to negative 2. So you should be copying this down in your notes right now. Still good popcorn. I'm almost done with it. All right. Delicious. So the first thing we're going to do is we're going to make a number line, and it has to have both of these numbers on it. So I've got the pen ready. Sorry about that. Pen. Go gadget pen. 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 There we go. All right. Graph the solution. Man, that's a really hard word. Solution set of x is less than 3 and x is greater than or equal to negative 2. So I need to get a number line that has both negative 2 and 3 on it. Man, promised you guys I wasn't going to use this pen. I have another pen. Let me try this one. That is actually worse because it's not even showing up at all. All right, my finger it is. 0, 1, 2, 3, 4, 5, negative 1, negative 2, negative 3, negative 4, negative 5. So we look to see what it means. First, we're going to graph this guy. So to graph x is less than 3, we go to our number line. We've got x is less than 3, so that's 3 is here. Less than 3 is this way. So I know it's going to be over this way. And then the other part says x is greater than or equal to negative 2. So that's right here. That's a filled in circle. And then that's shaded this way. Notice my two areas had some overlap. The overlap is where the solution set is, because that's both of the answers. So my final answer, I'll make a whole new number line. Zero, 1, 2. You have to have both numbers on the number line. So I see the solution set is where both negative 2 is, so here, I'm going to fill that in. It looks like it was all the way up to right where 3 is, but it doesn't actually include 3. So then my answer is this guy down here. So it's all the numbers between negative 2 and 3, including negative 2, but not including negative 3. So my answer is there, bottom, bam, answer. That's how we graph them. That's an example of an and, so that's pretty easy. I believe in you. You can do it. Let's do another example. This one we got to do some math first. So I need to get my variables by themselves. Go ahead and take a couple seconds, copy this down. Okay, enough awkward silence. So I've got y minus 3 is greater than or equal to negative 11. Got to get rid of that minus 3. So what's my inverse operation? Go ahead. I can't hear you. Plus 3. So I need to add 3 on both sides. When I do that, start from the left, work my way right, bring down my y. These cancel out. And I've got it's greater than or equal to negative 8. Now I do the other side. I've got y minus 3 is less than or equal to negative 8. Same concept. Need to add 3 on both sides. Bring down the y. These cancel out. F is less than or equal to negative 5. Now I need to go ahead and graph. This is an AND inequality, so it probably will look like the one that we just did. So I'm going to go ahead and make my number line. I need -8 and -5. I know the distance between those two numbers is actually fairly small. If I start out -9, -8, -7, -6, -5, I'm already there. The rest of this is just to fill in so that my number line doesn't look weird. Whoa, what happened to -2 there? Watch out, -2. All right. I know it's going to be a closed dot at -8. So there we go. I know it's going to be a closed dot at -5. And I can plug in test points to see if it's true. So if I plug in, it's another way of doing these. I can plug in is -6 greater than or equal to -8. Well, that's true. So I'm going to shade towards the -6 with this guy. So I'm going to shade towards the -6 with this guy. And then I can do the same thing with the other one. Is -4 less than or equal to -5? That's false. So I'm going to shade away from -4. So I'm going to shade towards that. Oh, cool. So this is like a range of values, saying that I could be anywhere between -8 and -5 and include -8 and -5 in on it. So there's another example. So it looks like for our and inequalities, most of them are going to go towards each other. So they're fist bumping for our and inequalities. Here's another example. This is also an and inequality. It looks a little bit weird. Go ahead and take a few moments to copy this down. This is the pin that doesn't work. Sorry, I'm distracting you. You should be copying this down. Checking my email. Checking my email. All right. Okay, hopefully you have enough time to copy down. With this one, we want to get the variable by itself in the middle. So it's got things on the outside. We want it in the middle by itself. So here's what we got. We've got 6 is less than or equal to r plus 7, which is less than 10. So to get r by itself, right now we're adding 7. So the way we're going to get rid of this, we're going to subtract 7. And if we subtract 7 from the middle, then we have to subtract 7 from this side of the equal sign and this side of the equal sign. Remember, my inequalities are like equal signs. So we're doing it on every single side. So the way that this works, we take 6 minus 7, we'll get -1. It's less than or equal to. R just comes down. These cancel out. And then it's less than 10 minus 7, which is 3. Sweet. So now we actually have two inequalities in this. We're saying that -1 is less than or equal to r, which is less than 3. Well, if you think about this, r is kind of sandwiched in the middle between that -1 and 3. So if I draw my number line, and I put, I'm going to go ahead and do blue for over here. So if I graph this part, I'm saying r, -1 is less than or equal to r is greater than or equal to -1. A few of you think of it like that, you got to flip it around. So if I plug in a test point, what I'm saying is -1 is -1 less than or equal to, let's plug in 0. Is that a true statement? Well, -1 is less than 0, so that's true. That means I'm going to be shading this way towards the 0. And then for my other shading, let's use green. Can't hardly tell the difference. That's right. R is less than 3. So if I did that, is 2 less than 3? Well, that's true also. That means we're going to start at the 3, shade towards the 2. But you can kind of see that continues on and they meet up. So it's another one of the and inequalities where they're giving each other fist bumps. So I'm going to use black. That's a filled in dot, that's an open dot, and then it's shaded towards each other, like this. So there's 3 examples of and inequalities. And inequalities generally shade towards the middle, like this. Generally, not always, but generally. The next one we have are our or inequalities. Did I skip one? Yeah. Our or inequalities. So go ahead and copy this down. Graph the solution set of an or inequality. Graph A is less than 3, or A is greater than or equal to 4. Man, my voice is going out. This is not good. This is actually a fairly small graph. 0, 1, 2, 3, 4, 5. All right. So A is less than 3. So I might put my circle on 3. Is 2 less than 3? Is 2 less than 3? Is that a true statement? Yeah, it is. 2 is less than 3. So we're going to shade towards the 2. And we're going to keep on going, unlike what we did with our and inequalities. And the reason I stopped with the inequalities, because I knew that most of them are going to meet towards the middle. That's why I stopped shading at some point. Then we kind of went both ways. However, this just keeps on going. I know I'm never going to hit that other number. I'm never going to hit 4. Now let's go ahead and shade the 4. So I start at 4. It's filled in because of the equal to. So now I ask, is 3 greater than or equal to 4? It's not, so we're going to shade away from the 3. So we're going to shade this way. Oh man, that's crazy. So the or, what the or does is the or does kind of the exact opposite of what the and does. The and's trying to fist bump each other. Well, the or's just got in a fight. They're trying to go away from each other. So our ors move away, our ands come together. So there's an example of that. Next thing we got, this example problem. One of them's already done, but now we need to do some algebra on the other side because we need to get x by itself. Go ahead and copy the problem down. It says x is less than or equal to 9, or 2 plus 4x is less than 10. So let's go ahead and do some math. Minus 2 on both sides. These cancel out, and you get 4x is less than 8. My x isn't by itself. I need to divide by 4 on both sides. Cancel out, cancel out. I get x is less than 2. So for my number line, need to make sure I've got both. It's the weirdest 8 I've ever made. I need to have both 2 and 9. Here's an example of when this is a little bit weird. Sometimes your ors will do this. So I'm going to go ahead and graph the left one first. I'll use red. So is 8 less than or equal to 9? That's true. So 9 is going to be a closed circle, and it goes to the left. And you can kind of see that I'm already covering up what's going on with the 2. Let's see what happens anyway. I kind of just shaded most of this graph. I'm going to go ahead and use blue for both of this. So this says is x is less than 2. So I'm going to put an open circle at 2. And then is 3 less than 2? That's a false statement. So that means I'm shading away from the 3, so I'm going to shade this way. Oh, there's overlap, but since this is an or inequality, pretty much wherever the red part is true. So it's kind of just there as an extra. Sometimes this will happen with ors. Very rarely will this happen with an and where you have overlap. Sometimes it'll happen with an or. Basically, the solution set is bigger of the 2, so it starts from here and it goes all the way over to negative infinity. So my solution set is all the way from 9 to negative infinity. Pretty cool. Here's our last example, our super hard one. Basically, all I'm doing now is just solving inequalities, and then we're graphing 2 of them. So really, we're just kind of combining it. Mr. Brummond's cheating and putting 2 problems on one answer. Then you got to interpret it. So let's go ahead and do this. Change my pen. So I've got plus 4. So I'm going to minus 4 on both sides. So I have